Good morning, Algebra 1 students. So, Mr. Chen again. So, today I would like to talk about the Chapter 4, Algebra 1. So, Chapter 4 for Algebra 1 is about writing an equation of a slope-intercept form. So, basically just finding that from the y-intercept form. So, we can just use that to find out the position f of x. And also we can find out that the graph, y-intercept along with the slope. So let's start it all with the basic one. Okay, so for 4.1, so I'm going to put this out here to my Active Inspire. So this one is saying that write an equation of a line in the slope-intercept form. Okay, so let's find out what to do with this one. So it might be a little bit bright here, so let me just control this brightness. Okay, so, and also this one, let me just make it smaller. Okay, so as you can see that right here, so we do have the y-intercept and 2 points given. So first thing that we can do, okay, let me just minimize this one a little bit. Okay, once again. Okay, so now what we can do right here, so we can just find the y-intercept first. So the y-intercept, that would be considered 0, 1. And then all you need to do is just find the slope first. So using the slope formula, or can consider that's rise over run. So if the graph is given, we can always count it from this point to this point, count it down. Rise over run, as you can see that the rise would be considered -2. Okay, so 1, 2 units down. And then the run would be 1, 2, 3, 4 units to the right. So rise over run, -2 over 4. So which is -1/2. Another way you can do it, you can just apply the slope formula, which is y2 minus y1 over x2 minus x1. So then that'd be 1 minus -1 all over 0 minus 4. So which is the same thing. So 2 over -4, which is -1/2. So since we find the slope, the y-intercept, we just put it into the slope-intercept form. So the slope-intercept form for this one, we just consider y equals mx plus b. Okay, so y equals mx, so -1/2 times x plus the y-intercept, which is 1. Okay, so that's how you get into the point slope form. And now let's take a look at that, going back to the template here. So the other one, 4.2, so writing equation in point slope form. Okay, so using the equations point slope form. So let's do number 2 and number 5. Okay, let me just pull this one down. Okay, so for number 2, again, let me just shrink this one a little bit. It's too big. Okay, so number 2 is saying that write an equation in point slope form of the line that passes through the point 4, 7 and has the slope of -1. Okay, so this one is pretty straightforward. We do know that the point slope form, it's based off the slope formula. So it's considered y minus y1 equals the slope and times the quantity x minus x1. And again, always keep that in mind. This one we can always derive it, okay, from the slope formula. We do know that it's y minus y1 over x minus x1. If we try to cross multiply this one throughout, and then we do have n times the quantity of x minus x1 equals y minus y1. Okay, so basically it's just the same thing as the point slope form. And then what we notice about the point here, 4, 7, x1, y1, so it's a given position. And the slope here is given as -1. So plugging in numbers, so we got y minus 7, so that equals the slope, -1 times the quantity, x minus 4. Okay, so no need to convert that to the slope-intercept form. If you want to, you can always multiply it out, distribute at 7 on both sides. And now what about number 5? So this one is given with 2 different positions. So let's just rewrite it. So 6, 8 and then the other one is considered 9, comma 3. So anytime they see that f of something equals the constant, it's always the position, x, y, x, y. So for that one, and all you need to do, okay, let me change the color a little bit. Okay, let's change that to purple. Blue. Okay, so let's see right here. So using that, find the slope first, perhaps. So what we got here, the slope is considered x1, y1. Over here, x2, y2. So y2 minus y1. So 3 minus 8 over 9 minus 6. So it's negative 5 over 3. So once we find the slope, using that the point slope form, y minus y1 equals that the slope times the quantity, x minus x1. So again, plug in a number, so y minus 8, and then the slope, negative 5 third, and then x minus 6. Okay, so then that'll be the point slope form. So sometimes your teacher probably asks you to derive it all the way from the point slope form to the slope intercept form. We can always do that, distribute at a on both sides. Okay, so now let's see what else that we have for the rest of this. So 4.3, it's about writing the equation of a parallel and perpendicular lines. So you may notice that if two lines are parallel, the slope got to be exactly the same. If two lines are perpendicular, which means that they form 90-degree angle, so that means the slope got to be negative and reciprocal. Okay, so now let's do, okay, one of this. So the first one is all about matching. So as you can see that A here, 2x plus 3. So determine which of the line, if any, are parallel, perpendicular. Well, okay, let me just put it out first. So again, if two lines are parallel, so that means the slope got to be exactly the same. Okay, so let's put it right here. So compare and contrast. So it looks like this one, they're all written with different form. Like line A, it's written in the slope intercept form. And then for line B and C, so they're written in different form. Okay, so again, just want to make it smaller. So first thing that I want to do, convert that, the standard form to the slope intercept form. So what we found for line B, so 2y plus x equals 5. So that means 2y equals negative x plus 5. So basically what I did here, I just subtract x on both sides. And then divided by 2 both sides. So we do have y equals negative 1 over 2x. If you don't see the number here, that's just considered 1. But it's a negative, so negative 1 over 2, x plus 5 half. And then for line C, similar. So 4y minus ax equals negative 4. So isolate y by itself. So add ax on both sides. So we got 4y equals ax minus 4. So divided by 4 on both sides. So what we found here is y equals 2x minus 1. Okay, so compare and contrast. The slope of the first line, line A, is 2. So line A, line C, they're considered parallel because that they all share with the exact same slope. And then line A, line B, so those two lines got to be perpendicular. Well, because that's the slope here, compare and contrast. So they're considered negative reciprocal to each other. So 2 over 1, the negative reciprocals of that number, it's negative 1 half. So line A and B, so they're perpendicular. If you see the upside down T symbol, that means perpendicular. And then line A and C, parallel. If you see like a pair of chopsticks like this, that means the lines are parallel. Okay, so now let's see what else that we have. Going back to the template. And for the other one, write an equation of a slope, intercept form, then compare the slope. Okay, so this one, just rewrite it as the slope intercept form, compare the slope, as you can see that here. So basically, well, this one is just like what we're doing. So let's just skip that one. And the next one, okay, let's see. This one is just an example, that's why. And then determine which lines if any, are parallel perpendicular, similar to what we're doing. Let's do number 8 and 9. Okay, so write an equation of a line that's passed through the point, and which is parallel to the given line, and the other one's perpendicular. Okay, so again, just want to make this one a little bit smaller. Okay, so given with that point, 1, 5. Okay, so let's say that x1, y1. And then the given equation with the keyword parallel. Again, parallel, that means we want to find out the exact same slope. According to the equation of a line right here, the slope is -4. And we do have a point, 1, 5. So for number 8, it's actually pretty straightforward. So basically plugging a number to the point slope form. So we got y minus 5, so that equals the slope, -4 times the quantity, x minus 1. So write an equation of a line. So sometimes your teacher just allow you to just put it this way, or sometimes you have to simplify it all the way down. So what I would like to do here, I would like to simplify it all the way down. So f5 on both sides. At the same time, you want to distribute. So we got y equals -4x plus 4 plus 5. So that means y equals -4x plus 9. So that would be the equation of the parallel line. And then number 9, again, the point's given, so label it, annotate, so x1, y1. And we do know that the key word is perpendicular. Perpendicular, that means the slope got to be negative reciprocal. So let's find out the slope of the given equation here. It's -2. So that means the brand new slope here, then that would be considered 1/2. Because we need to take this number to its negative reciprocal. So negative times negative, positive. And then reciprocal, that means we need to flip the numerator and the denominator over. So we got 1/2. Again, using that, this point slope formula. So y minus y1 equals m times the quantity, x minus x1. So y minus -3, so the slope, 1/2, and then x minus 2. Again, this one, we want to simplify it, so negative, negative, positive. So y plus 3, so that equals 1/2 x minus 2. So 1/2 x minus 1/2 times 2, -1. So y equals 1/2 x. Subtract 3 on both sides, so we got 1/2 x minus 4. So the equation of the perpendicular line. Okay, so now the next section is about the scatter plot. And I'm sure that I did one of the video regarding the scatter plot, like using the calculator. So that's why the next section, 4.5, so I'm not going to continue with that 4.5. So instead we'll jump to the 4.6. But let's do the one manually with the scatter plot. So this one is a scatter plot and the line of the best fitting line. So this one is about estimation. So what's the roasting time for 12 pounds of turkey? Okay, so 12 pounds of turkey is right over here. If you just read through the instruction, the dot, so the corresponding value for the time, then that'll be 4.0 hours. Okay, so 4.0 hour. Okay. And then number 11, so that's the one I'm going to show you. Write an equation that models the roasting time as a function of weight of turkey. Interpret the slope and the y-intercept of the line best fit. Okay, so 11 along with the graph. Okay, so I'm going to just pull out the whole slide right here. Okay, so let's check that out. And let's put it right over here. Okay, so again, that's too big. Okay, let's make it smaller. Shrink it. Okay, so first thing first, so we do know that the graph given here, it's about the weight versus the roasting time. Okay, so you can just choose any 2 points randomly, because the best fitting line is that if you just make a straight line going through. So this one can go through as many points as possible. So this one is called the best fitting line. And again, throughout the line right here, I just want to choose 2 points. So perhaps choosing this one and this one because they're kind of further apart. So according to what we got right here, this one is about 20. So for the 20 weighs pound turkey, so the corresponding roasting time will be considered 5.5 hours. And then if the weight of the turkey, it's considered 4.0, 12 pounds. Then the roasting time would be about 4 hours. Okay, so I'm going to choose those two numbers. Well, the reason why that is because I want to find out the slope. Because once you put in the best fitting line right here, you can always estimate the slope. So again, using the slope formula, y2 minus y1 over x2 minus x1. So give the name for the number. So x1, y1, x2, y2. So we got 5.5 minus 4 all over 20 minus 12. So 5.5 minus 4, then that would be considered 1.5 divided by 8. So this one, I don't want to deal with decimals, so let's multiply 10 top and the bottom. So we got 15 over 80. And then this one divided by 5, top and the bottom. So we got 3 over 16. So the slope would be 3 over 16. And then for the y-intercept, so in order to get the y-intercept here, so we want to generate it with the point slope form. So y minus y1 equals m times x minus x1. You see that the graph here, so the squiggling line, that means we don't start it at 0, 0. So we don't know what the y-intercept is. So let's find out that by plotting the point. So x1, y1, so y minus 4. So the slope is 3 over 16. And then x minus 12. Now, for those you might be wondering what happened if I just multiply by 16 both sides. Certainly you can do that. But let's just give it as the weight it is, because we want to distribute that next. So we got y equals 3 over 16, x minus, so 3 times 12, that's 36. So 36 over 16. And then negative 4, just add 4 on both sides. In other words, that means you're adding 64 over 16. So that means y equals 3 over 16x plus 64 minus 36, then that'll be 28. Okay, so 28 over 16. And then 28 over 16, is that reducible? Yes. Divided by 2 top and the bottom. So 3 over 16x plus 17 over 8. So 17 over 8, that's about 2 point something. Okay. Yeah, so for those you might be wondering the y-intercept, what does that mean? So for the 2 point something hours, so that means it's like a preparations, or taking the turkey for roasting, okay? So here's the equation. And also we need to interpret the slope in the y-intercept. So 3 over 16. So the average time to roast the turkey, it takes about, well, for 1 pound of turkey, it takes about, you can say that for 16 pounds of turkey, it takes 3 hours. So it shows the rate of change. So this one, it shows the rate of change of roasting the turkey. And then 17 over 8, it takes about the time for preparing roasting the turkey. Well, because you need to marinate it. You need to put in some kind of ingredient to make it, taste good. So 17 over 8, it would be the preparation time before you put the turkey to the roaster. Okay, so now, and let's see, any other questions that we have? Okay, so besides this one, so let me go on to the next slide here. Again, the next one, the scatter plot, we're not doing that. So for the calculator, I actually explained that in one of those videos. So make sure that you check that, the scatter plot, along with the best fitting line. And then 4.6 is about the arithmetic sequences. Okay, let's talk about this. Arithmetic sequences is about like the pattern from one term to the next number. So either by adding or subtracting. So we'll do 15 and 17. Okay, so let me put it to the new page right here. Okay, so 15 to 17. So write an equation for the n term of the arithmetic sequence, then find the value of a sub 30. A sub 30, that means you want to find out the number of the 30th term. So start it off with 15. So as you can see that from 11 to 10. So we want to subtract 1 from 10 to 9. We want to subtract 1. 9 to 8 minus 1. So a sub 1, the first number, it's considered 11. And then the common difference here, it's negative 1. So in order to come up with that, the n term of the arithmetic sequence, so the general formula, it's considered a sub n, so that equals a sub 1 times it's a sub 1 plus n minus 1 times the common difference. So a sub 1, it's 11, plug in a number, and we don't know what that is, we can go as many terms as we want, minus 1, and then d is the common difference times negative 1. So that's a sub n, the general formula. But the things that we can simplify it a little bit, so 11 plus n times negative 1, that's negative n. Negative 1 times negative 1, that's positive. So then that'd be 12 minus n for a sub n. So in order to get that to the 30th term, so the 30th term would be a sub 30th. Then that'd be 12 minus 30. So 12 minus 30, which is what? 18. So keep going. So the number is going to be getting to negative, well, it's negative 18, excuse me. So it's going to be negative 18. And then number 17, so a sub 1, that's negative 9. Common difference here, from negative 9 to negative 6, we add 3. Would that be the same story for the next number? It is. Add 3. Keep adding 3. So the common difference is 3. Again, a sub 1, it's negative 9. Applying the same kind of concept, the same formula that we have for a sub n. So it's a sub 1, negative 9, plus the quantity of n minus 1 times the common difference. Again, this one distribute. So we got 3n minus 3. So negative 9 minus 3, then that'd be negative 12. So negative 12 plus 3n, a sub n. Again, find out the number of the 30th term. So plug in 30 for n. So we got negative 12 plus 3 times 30. So 3 times 30, that's 90. So 90 minus 12, which is 78. Okay, so 78. Okay, so now going back to the template, the last section that we have, piecewise function. So this one we need to talk about a little bit more, piecewise functions. You know, for some school, they don't start with the piecewise function until the student get into either Algebra 2 or pre-calculus. You know, some school, they started in 7th grade, you know, for Algebra 1 or maybe like pre-algebra, okay? So let's look at that, the piecewise function. If that's a piecewise function, as you can see, that's a plural. So that means it's getting involved with more than one function. And also this one, it shows like a different domain and range for the function. And as you can see that here, if x is less than or equal to 0, if x is greater than 0. So what this one does, it shows the restriction. It shows that the different restriction for the function. Okay, so now let's do the basic one. Let's start it with the one that it requires graphing. Okay, so let's do number 19. So this one, just find, well, let's just sketch the graph first, and then we want to define the domain and the range. Okay, so for number 19. So the first part of the piecewise function is a linear function, so x plus 6. So identifying the slope, well, the coefficient is not shown, it's always 1. So rise over run, it's 1 over 1. The y-intercept, then that'd be 6. But the things that keep that in mind, as what I mentioned about, this one, it shows the restriction. So the restriction for the first part of the piecewise function is x is less than or equal to 0. So that means instead of just using the slope and the y-intercept, we just want to utilize some of the number. So we just want to plug in number that's less than or equal 0. So we can plug in 0. So plug in 0, so the y-intercept is 6. And then the next number that I want to put in here, negative 1, because that's less than 0. so negative 1 plus 6. Then that would be 5. And then negative 2, so negative 2 plus 6. Then that would be 4. And then for the xy table that we have, so now you can plot the points. So with the y-intercept, so 6 units, 1, 2, 3, 4, 5, 6 up here. And then the next one, negative 1, comma 5, negative 2, comma 4. And then the next one should be negative 3, comma 3. Okay, so just keep going and going. So on and so forth. Okay, so negative 2, comma 4 should be a little bit higher. Okay, so 1, 2, 3, 4, 5, 6. And then the rest of this, you just want to connect those dots. Okay, so for the negative 2, comma 4, I should raise up this one a little bit higher. So eventually it's going to be going this way for this part of the piecewise function. And then the other part of the piecewise function is negative 3x. So the slope here, it's negative 3. And the y-intercept is not shown, then that means it's what? 0. So the y-intercept for the second part of the piecewise function, 0. But this one is for anything that x is greater than 0. So again, xy table, so plug in 1. You can always test that out at 0 and see what happens. Sometimes it might be considered connected. If you plug in 0, this one is showing that it's considered nothing. So we started kind of at the origin here. But that position is not included. So you plug in 0, it's showing that it's 0. But at this position, it's not included. Okay, not included. So that's why I put in the open circle. And then at 1, what happened at 1? 1 times negative 3, that's negative 3. So 1, comma, negative 3. 1, 2, 3, down here. And then you want to keep going. So 2 times negative 3, negative 6. So 4, 5, extend it, 6. Okay, so all the way down here. And then simply just connect them. So again, piecewise function, it shows more than one function. Sometimes could be 3 part of the piecewise functions. And also the main part of the main purpose of doing that is sometimes you'll see that it's like going to a different direction. And sometimes you're being considered connected. Okay? So for the piecewise function. And now going back to the template. And let's see what else that we have right here. Write the absolute value function as a piecewise function. So this one could be a little bit tricky. Okay, so let's do that. Okay, so for number 22. So you might be wondering, how do we separate the absolute value into piecewise functions? Okay, again, as what I mentioned before, normally you don't do this until you get into either Algebra 2 or pre-calculus. But due to the Common Core, it's always raising up the rigorous, the connectivity, the relation with one class to another class. So that's why, some schools, they introduce those type of concept earlier. It's like early preparations for a student getting into like integrated math or accelerated math program. And what we can do here, as you may notice that we do have y equals a times x minus h plus k. So the things that you want to identify the value of h. Because h right here, it's the x value of the vertex. So the x value of the vertex. So if you guys do refresh that, the absolute value functions, it's a V-shaped graph. So h comma k, it's always the center or the vertex of the graph. So once you allocate the value of h, so which is what, negative 5 in this case. So that means negative 5, we can break it apart into negative, positive. Okay, so try to sketch the graph for this one. So it's showing that at negative 5, 1, 2, 3, 4, 5, right here. So showing that this part is going this way, and the other part is going this way. And you might be wondering, well, how do I get this kind of a V shape? It's all about the slope that we have. So the slope here, it's considered 4 over 1. So it's 4 units it's 4 units up. So 1, 2, 3, 4, 4 units up. And then it's considered 1 unit over to the right. Okay, so this one, yeah, I should make the scale better. Okay, let's start it over. Okay, so started with that, the x-axis, y-axis. So let's set up some scale. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, so again, the vertex is negative 5, comma 0. And then the slope, so 4 units up, 1, 2, 3, 4, 1 unit to the right. And then the other side, similar, 4 units up, 1 unit to the left. So you may notice that it's a skinny V shape. So by the time they separate the function into a piecewise function, so the first half of it, it got to be the one from the negative. Because the slope here is negative, going down. So negative slope, so that means we started off with negative 4 times the quantity of x plus 5. Again, we just want to keep the same kind of consistency, the vertex, which is what? At x equals negative 5, the slope this time is what? Negative. And this one is saying that x is less than negative 5. And then what about for the positive slope? The positive, then that would be positive 4 times the quantity of x plus 5. And for this case, x is greater than or equal to negative 5. Again, the vertex, the value of h, it shows that the breaking point. Okay, so this one is f of x or y. Okay, so now let's see what else that we have for the rest of the template here. So the other one, you want to set up the piecewise function from the word problem. Okay, so let's look at that. So the last one that for this whole unit here. Okay, so I'll put it to the new page. So you're organizing a school fair and rent a popcorn machine for 3 days, and the rental company charges $65 for the first day and $35 for each additional day. And write and graph the step functions. Step function is just the piecewise function that represents the relationship between the number x of days and the total cost y in dollar of renting the popcorn machine. Okay, so this one is an interesting one. So for the first day, okay, so let's just break it apart. For the first day, so the school paid for $65 for renting the machine, the popcorn machine. So day 1, first day, so spending $65. And then for each additional day, the school spent $35. Okay, so the second day and the third, and also the third day. Okay, let me just change that. And third day. So spend $35 on each one of those 2 days. So write and graph the step function. So the first one, so $65. So this one is for, okay, so let's see the date. So D would be considered day 1. Okay, day 1. So anything that D is less than or equal to 1, that's considered day 1. Okay. And then for second day and the third day, so the school rent for the same machine. So then that'd be 35 times x. X would be the number of days. So instead of using D, let's say x. So x is less than 1 or equal to 1, but it's also less than or equal to 0. So after day 1, so that means anything that after day 1, so from day 2 and then all the way to day 3, the end of day 3. So the school spent $35 per day to rent a popcorn machine. So here's what we found. So they're both considered a linear function. And then this one is saying that it's f of x, the cost. Or can say that c of x. Okay, so y or y. Okay, so sketching the graph here. So from 0 to 1, so the school's spending $65. Okay, so this one, let's use 10, 20, 30, 40, 50, and then 60. 65, that's somewhere here. So from 0 to from 0 to 1, so the school spending $65. And then from day 1, anytime after day 1, so the school spending $35 on each day to rent the popcorn machine. So 35, so that would be the slope. Okay, so this one you just want to find out exactly what's happening. Y-intercept here would be 0, so 35, if you just consider that it's like the cost for the rest of those days. Okay, so that's going to be like a step function or the piecewise function from day 1, day 2, day 3. But one thing that I need to be careful here, so saying that x is from day 1 to day 3, okay? So for this one, also, the time, you probably want to do something here. Because once you multiply by 3, then that would be the charge for those 3 days. Okay, which doesn't make sense. So I would say that x minus 1. Okay, gotta be very careful for that one. The reason why that I put in x minus 1 is that for day 1, it's only paying for $65. And then day 2, so 2 minus 1, then that'll be just for 1 day. And then 3 minus 1, then that'll be just for 2 days. So this one's supposed to be 35 times the quantity of x minus 1. Try to simplify this, so it's 35x minus 35. So negative 35, that's somewhere down here for the y-intercept. Okay, so negative 10, negative 20, negative 30, negative 35, that's somewhere down here. And also, you can always apply that to XY table to find out exactly what happened. So what happened at 1 day? So 35 minus 35, that's 0. Because that at the end of the day 1, you don't have to pay for anything. But this one is not a closed circle, it's an open circle. So that position right there, it should be open circle. Because that position is not included. And then day 2, so 2 minus 1, 35. So 35, which is up here. And then day 3, so 35. So 3 minus 1, 2. 2 times 35, 70. So 70 is all the way up here. So once you connect them, so it's going to be like this. So this one is called the step function or the piecewise function. Again, what I do here, just like an XY table. So plug in 0, plug in 1. So we got 35, which is not included. And then plug in 2 right here, we got 35. No, if you plug in 1 here, that's 0. Excuse me. And then plug in 2 here, so 2 minus 1, that's 1. 1 times 35, that's 35. Plug in 3, so we got 2. 2 times 35, 70. Okay, so that's what we found. So the domain and the range. So the domain here, so pretty much that covers all the way from 0 to 3. The range, it covers everything at this position here, at 0. The range would be from 0 to 65. Well, from 0 to 70, actually, that's the range. Okay, so just watch out for things like this. So x, the number of dates from 0 to 3, and then for the range, well, at this position it's supposed to be open circle, because that, if you don't rent it, you don't have to pay for anything. So 0 all the way to 70. Okay, so that's it. Thank you for watching the video today. So make sure that guys to look at that more, all those area there in the concept of the piecewise functions, because this one could be very complicated. So again, utilize that the video, so hopefully that can help you to solve for some of the problem. Okay, so thank you for watching it. I'll see you guys next time. Take care.